Hey guys, so I haven't done a video for a few days because I've been working on some stuff here. In the best example of if it's not broken, don't fix it. I went and I was trying out this power supply with this unit here, and I figured I could get more current. It's a little bit higher voltage. Those drivers could take the higher voltage. And I figured I might be able to get some higher speed out of this thing here. But of course, what happened was one of the drivers died on me. And I don't think it was related to the power supply. When I was doing some subsequent work, I found a loose connection, a cold solder joint actually, in one of the connectors on the end. These are different connectors right now. And, you know, like these drivers state specifically that you can't disconnect them when they're... when there's power applied, otherwise you'll damage the driver. So that's probably what happened to that one. Nonetheless, I didn't have any replacements, so I decided I was going to wire up this thing. And what this is the Gerbil shield, or GRBL shield, that I mentioned from an earlier video. And it's actually a pretty simple wiring job. It's basically you're just wiring up, you know, your power supply, which is, this will go to that unit. And your stepper motors, and that's about it. There isn't a hell of a lot in here. If I could have fit it, I would have fit the power supply in here, but it's a little bit, you know, too big to fit in this box. And eventually, I'll migrate this all to another container. Now, if you also have good memory, you'll also remember I mentioned that this power supply was too high voltage. So what it is, I opened it up and I modified it so that I could. You know, I had a little bit lower range for the adjustment, and I set it down below the maximum 30 volts that this thing is supposed to be capable of taking, to right around 27 volts. You know, like I figured that was a good split between maxing it out and that. So what I'm going to do today, oh yeah, and before I took the old system apart, you know, like I did some numbers here where I was just doing some tests to see what the maximum feed rate was for all three axes, and I came up with numbers like 15 inches per minute for the y-axis, which is exactly what I was already using, 25 for the z, and 25 for the x, which was, oh actually no, I got that wrong. I'm looking at the numbers, I just glanced over there. It was 15 for the x and 25 for the y and the z. So what I'm going to do is I'm going to wire this one up, try and get at least those same numbers, and then I'm going to crank the current up and see if I can get some higher speed numbers. Now, when I was doing my testing before I blew everything up, I was finding that I could get pretty high seek rates in the middle of the travel, where there was low friction. Now, where it goes to the end, there's a little bit of misalignment with something, I suspect, and things like, you know, it's either in the lead screw or it might even be in the guide rods here, or guide pipes, for lack of a better way of putting it. In any case, when it gets to the ends, that friction comes up, and that's when I was seeing those lower numbers that you're seeing. But I was seeing actually some fairly high seek rates of around 50 reliably, and I was seeing as high as 80, you know, although it wasn't consistent. So anyways, so I'm just hoping I can split the difference, maybe speed this thing up to about 30 inches a minute, which would be twice as fast as I was letting it go before, and let me cut things a little bit faster. I did notice that with the higher seek rates, vibration started to become an issue. I'm not talking about vibration of the spindle. I'm talking about that this thing would start to shake, literally. And I said to myself, well, okay, that's never going to work for anything you want to do, other than for a rapid that's not under load, which is a possibility. You know, like even if the feed rates under load aren't much higher, I can increase the speed of the rapids when it's, you know, seeking above the surface to move to a different position. That, you know, might, you know, decrease my times a bit as well. We'll see. In any case, let's start some testing here. I got some material. Vicky went and picked me up some cutting boards I'm going to try and cut up at some point and see how well that mills. But it's just kind of an aside. I've already laid out some CAD drawings and created the G-code files for creating the frame for the Prusa i3 3D printer. So I was hoping that I could get going on that last weekend, but it didn't work out because I blew up the driver. I got the replacement parts today for that, but you know, in the meantime I was working on this one here and redoing some of these connectors. These are some, you know, I don't know what I want to call them. I guess they're microphone connectors, but they're fairly heavy. I don't think it's going to be a problem, you know, pushing, you know, 2 amps through them. You know, previously what I was using was DB9 connectors. I don't know if I got a sample here so I can show you what I mean. Considering the fact that these are supposed to be rated for 5 amps per terminal, I don't figure that 2 amps through a much larger connector is going to be a big problem. But we can see, you know, you'll be able to feel it in the connector if it starts to heat up. In any case, I'm babbling for 6 minutes now. So I'm going to reconnect all this stuff up and give it a go and see how well it works for me here. And then I'll show you guys the results. Okay, so it's all working. I haven't even changed any of the settings on the board here. And works, it moves. The only thing I'm not sure about is it's making it's a different noise. There's an initial hum and all that, and it does it on all the axes. Now I have to verify by using a plunger and all that, or not a plunger, but my dial indicator, and make sure that it is indeed moving the amount that it's supposed to be moving. But I'll take care of that. Well, maybe I'll take care of that shortly, but nevertheless, so now I'm going to do some tests with feed rates, and I'll bring you back when I figure out what the maxes are for that. So, looks like this will work. I'm just a little concerned about the different noise. It's actually less noisy, which is probably a good thing, but that initial hum makes me wonder if it's immediately losing steps right at the start, so I'm not 100% sure what to make of that. Anyways. Okay, so I've been doing some testing here, and I've done the y-axis, and I figured out that it would seem that the maximum reliable feed rate that I can do on the y-axis is about 100 inches per minute, which is pretty impressive. I don't think I would ever run it that fast because you can hear the motor rattling away there. You know, like it's probably the bearing isn't quite tight in here, maybe the lead screw isn't quite tight. Something along that line, you know, like you can hear the vibration. Also, I'll do one seek. I'll just show you how fast it looks normally here. Now, I suspect a lot of that rattling is probably the lead screw, because what I'll do is I'll feed you back the other way, and you can actually see the lead screw is probably either slightly bent, or you might be seeing, I think it's slightly bent, but you might be seeing something that's called lead screw whip, where it whips around like a jump rope. But I don't think that's what you're seeing. I think you're seeing a bent lead screw, but nonetheless, or a slightly misaligned one. Anyways, we're going to just go, and I just got to verify I'm going in the right direction, and yeah, I'm pretty sure it's a bent lead screw, but nonetheless, you know, like that's when you're seeking that fast, that's actually you know, pretty much stressing the machine to the limit. Yeah, I'd never cut at that speed, not unless I was cutting foam or something like that. But even then, that's pretty fast. But it's good to know. So now we're going to try the x-axis, which was a little bit more particular with the old card. This new card actually seems a lot better than the other setup, which actually surprises me, but actually has a slightly higher rating. It's rated for 2.5 amps per phase, whereas the other one I believe was rated for 2. But nonetheless, I put some heat sinks on it, and when I put it back together, I've got a fan here. that will be directly blowing on top of that. Now they say you actually want to cool the bottom of it because there's as much heat dissipated off the bottom as there is off the top. They actually say more. But this is the best I can do for the moment. At some point, if it becomes critical, then I'll rejig this case, or I'll make a new case, and I'll actually have another fan to blow in that direction. But obviously it's not going to be very effective for the direction of the fin, so you kind of almost want two different directions of flow. We'll work it out. So in any case, now I'm going to test the x-axis and see what it's going to like for a seek side to side. The Z is not going to be quite as critical, but you know, when you're doing things like plunge drilling holes, where it's, you know, it's taking the pecs on the holes, the Z speed actually is pretty important, but not so important for pretty much every other operation, because you're not tending to change the Z axis really rapidly. You can see all that gunge on that bit, eh? That is not actually burns, other than the wood may be burned. You know, I've cleaned it off before, and the bit looked fine. It wasn't blued. It looks blued, but there's actually some kind of black gunge that actually chips off of it. I can't get it off here, not that way, but you know, nice and sharp still. You can actually see some of the black stuff might have fallen down there. Anyways, I'm really just a random guy, aren't I? I'll do the next test and I'll let you know. Okay, so I did a little testing on the x-axis, and it's a little bit slower max feed rate. It's about 70 inches per minute, but that's still plenty, and more than I'll use, certainly. So I'll just give you a quick demo of that. Now it kept stalling out for me about 2 to 3 inches in, and whenever I exceeded that number, I tried adjusting the current, and it didn't seem to make a lot of difference. Although bumping it up did increase it, you know, like significantly. Like initially it started out at the default value of probably about, I think I might have gotten 30 inches per minute out of it. But nonetheless, it seems to be working fairly well. There's probably some other testing that I could do is the acceleration parameters. You can notice obviously it doesn't start out at full speed. And I might be able to, you know, increase the acceleration parameters, but that's going to be, you know, like one whole other enterprise there. And quite frankly, I'm not as worried about that. It would increase the speed as much as increasing the feed rate would, but I'm not going to worry too much about that. So next test is Z-axis feed rates. Like I said, unless I increase the acceleration parameters, I'm going to ultimately be limited by that. Because you saw how long in that last video, how long it took for it to come up to full speed anyways. It took a couple of inches. So if I'm only ever feeding this thing up and down by, let's say, a maximum of 3 inches, you know, unless I increase my acceleration parameters, 70 inches per minute isn't even going to enter into it. It's never going to hit that speed. But we'll do some testing and see how that one works. Okay, that didn't take too long to determine that. Looks like the maximum feed rate I can get out of this thing is about 60 inches per minute. So we'll just do a quick seek up. Now here's one axis where it would make a lot more sense to tweak the acceleration parameters and see how that works. Because like anything, to be able to do those pecking, the plunge drilling operations, it obviously is fairly important to be able to go fairly fast. And you're really only seeking, you know, you might be seeking on a 3/4 inch piece of material. The maximum you're seeking is going to be maybe an inch or maybe 7/8 of an inch, kind of a thing. So kind of important to get that parameter right. So I'm going to play around with the accelerations, but I think unfortunately the version of Gerbil, or I call it Gerbil, but it's GRBL. I believe it doesn't have separate acceleration parameters for each axis. I think that's scheduled for version 0.9, and I'm running 0.8C. So, we'll see how it goes. I'll let you guys know what I find. Well, not surprisingly, there's always an afterword, or postscript, whatever you want to call it, to my videos. I didn't get very far into my air cut, and I plowed lost some steps and it plowed the x-axis into the other side there and derailed things. So that proved two things. One is I think I'll just stick with my original feed rates and just deal with how long it takes, because I wasn't too impressed with that. I also am going to have to do one thing that I've never mentioned, I don't think, in any of the videos, and that is add some limit switches to the machine so it can't damage itself. I was lucky in this case; it just pulled these lead screws out and rammed them, you know, and wound them into the end. Or sorry, not the lead screws, but the nuts here into the end. But the reality is, if those were any tighter, it would have probably damaged something. Certainly stalled out the motor and maybe overheated it. Who knows? So what I need to do is I need to add some limit switches to these things. X, Y, Z. You know, Z is a little more questionable because, you know, at the top, you know, like, I guess it's good to have it stop, but, you know, like, you'd have disaster long before it ever hit a limit switch on the bottom, because you could see that this would have crashed, you know, long before it ever hit the bottom here. But that's going to certainly be something I'm going to have to add very shortly. Nonetheless, I'm going to come out here tomorrow and run the frame, and we'll see how we go. So thanks, guys. Thanks for watching, rating, commenting, subscribing. See you later.